The rated capacity for an 8-gauge stranded copper wire is 30 amps. This rating is crucial for ensuring electrical safety and preventing overheating of the wire. Several factors influence a wire's ampacity, including the wire gauge, the material it's made of, the insulation type, and the ambient temperature. Wire gauge refers to the physical size of the wire, with smaller numbers indicating larger wires. Larger wires can carry more current because they have less resistance. Copper is a common choice for electrical wiring due to its high conductivity. Different types of insulation are rated for different temperatures, which affects the wire's ampacity. Higher temperature rated insulation allows the wire to carry more current safely. The ambient temperature, or the temperature of the surrounding environment, also affects ampacity. Higher ambient temperatures reduce the wire's ability to dissipate heat, lowering its ampacity. National Electrical Code, or NEC, tables provide ampacity ratings for various wire sizes and insulation types under specific conditions. It is important to consult the NEC for accurate and up-to-date information. Understanding and adhering to ampacity ratings is essential for safe and reliable electrical installations. Overloading a wire can cause it to overheat, potentially leading to fires. When determining the appropriate wire size for a circuit, it's important to consider the load it will be carrying, as well as any voltage drop that may occur. Voltage drop is the reduction in voltage along the length of the wire due to its resistance. Excessive voltage drop can cause equipment to malfunction. To minimize voltage drop, it's often necessary to use a larger wire size than what's required for ampacity alone. For example, if a circuit requires 25 amps, an 8-gauge copper wire with an ampacity of 30 amps may seem adequate. However, if the circuit is long, voltage drop may be a concern, and a larger wire size may be necessary. In addition to ampacity and voltage drop, it's also important to consider the type of load the circuit will be serving. Continuous loads, which are loads that operate for 3 hours or more at a time, require special consideration. The NEC requires that the overcurrent protection device, such as a circuit breaker or fuse, be sized at no more than 80% of the wire's ampacity for continuous loads. For example, if an 8-gauge copper wire is used for a continuous load, the overcurrent protection device should be sized at no more than 24 amps. This helps to prevent the wire from overheating due to the sustained current draw. When selecting a wire size, it's also important to consider the installation method. Wires installed in conduit or cable trays may have different ampacity ratings than wires installed in free air. This is because the surrounding materials can affect the wire's ability to dissipate heat. The NEC provides specific ampacity adjustment factors for different installation methods. It is essential to consult these factors to ensure that the wire is properly sized for the application. Furthermore, the number of current-carrying conductors in a raceway or cable also affects ampacity. When multiple current-carrying conductors are bundled together, they generate more heat, which can reduce their ampacity. The NEC provides rating factors for adjusting ampacity based on the number of current-carrying conductors. It's important to apply these rating factors to ensure that the wires are not overloaded. To summarize, the ampacity of an 8-gauge stranded copper wire is typically 30 amps, but this rating can be affected by several factors, including insulation type, ambient temperature, installation method, and the number of current-carrying conductors. Always consult the NEC and other relevant standards to determine the appropriate wire size for a given application. In practical applications, understanding these nuances is critical for ensuring electrical safety and compliance. For instance, consider a scenario where an 8-gauge copper wire is run through an attic with a high ambient temperature. The increased temperature would necessitate a rating of the wire's ampacity. This means that the wire could no longer safely carry its rated 30 amps. The specific rating factor would depend on the exact temperature as specified in the NEC tables. Similarly, if multiple 8-gauge wires are bundled together in a conduit, their combined heat generation would require a further reduction in their allowable ampacity. The NEC provides specific rating factors based on the number of conductors in the conduit. In industrial settings, where machinery often draws significant current, careful consideration of wire ampacity is paramount. Using undersized wires can lead to overheating, insulation damage, and even electrical fires. Regular inspections and maintenance are essential to identify and address any potential wiring issues. Proper labeling of circuits and wire sizes is also crucial for ensuring that electricians and other personnel can safely work on the electrical system. Furthermore, advancements in wire technology have led to the development of higher temperature-rated insulation materials. These materials allow wires to carry more current at higher temperatures, potentially reducing the need for larger wire sizes in some applications. However, it's important to carefully evaluate the specifications of these newer wire types and ensure that they are compatible with the intended application. In addition to copper, aluminum is another common material used for electrical wiring. Aluminum wires have a lower conductivity than copper wires, which means they require a larger gauge to carry the same amount of current. The NEC provides separate ampacity tables for aluminum wires. When working with aluminum wires, it's important to use appropriate connectors and terminations that are specifically designed for aluminum. Aluminum is more prone to oxidation than copper, and improper connections can lead to increased resistance and overheating. Regular inspections and tightening of connections are essential to prevent these issues. In summary, selecting the appropriate wire size for an electrical circuit is a multifaceted process that requires careful consideration of various factors, including ampacity, voltage drop, load type, installation method, and ambient temperature. Consulting the NEC and other relevant standards is essential for ensuring electrical safety and compliance. Using undersized wires can have serious consequences, including overheating, insulation damage, electrical fires, and equipment malfunction. By understanding the principles of wire ampacity and following best practices for electrical wiring, it's possible to create safe and reliable electrical systems. Furthermore, continuous education and training are essential for staying up to date with the latest advancements in wire technology and electrical codes. The electrical industry is constantly evolving, and it's important to remain informed about new products, techniques, and regulations. By investing in education and training, electricians and other electrical professionals can enhance their skills and knowledge, ensuring that they are able to provide safe and reliable electrical services. The importance of proper wiring practices extends beyond individual projects and into the broader community. Safe and reliable electrical systems are essential for supporting economic growth, providing essential services, and protecting public safety. By adhering to electrical codes and standards, electrical professionals contribute to the overall well-being of society.